Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So today I would like to present my mini project. Okay, for introduction, the location chosen based on figure given. The location given is Majlis Pemandangan Muar, which located in Muar, Johor. The location selected because Majlis Pemandangan Muar had renovated their building to make an office. The officer in Majlis Pemandangan Muar request to me to handle for adding air conditioner system and the building including ducting system. So me as an engineer to design and calculate the ducting system. And flow, this is a floor plan selection, and the building type is office, and its width is 100 feet, its length is 120 feet, and its height is 12 feet. Okay, methodology. This is the first step of calculation, which is cooling load estimation. So for the first step, we need to calculate the cooling load estimation. To continue for the next calculation. So for this calculation, we need to identify the specification of the building, so we can calculate the cooling load estimation. And this is the second step of calculation, equal friction method. It is divided by 5 steps. And for the first step of this second step is determine area required of the room, CFM. The below is the formula of for the first step, which is CFM equal to RSH divided by 1.9 times 22, which is the total division. And step 2 is calculate required diffuser. The formula is required diffuser equal to CFM per diffuser. CFM per diffuser is we need to refer to catalog. And the right one is step 3, draw a schematic ducting system. The picture below is just an example for the step 3. And the step 4 is determine throw radius. For the length side is 1 throw equal to room length dimension divided by nose number, and for the width side is 1 throw equal to room width dimension divided by nose number. Just same formula. And to verify the throw radius, we need to plus the length side and the width side and divide by 2, and then we'll get the throw radius. And then for the step 5 is determination of ducting size. We need to find all the information in this table. And the right side, for sectioning, we need to determine our section for every room for the ducting system. And the CFM is we calculate from the previous formula. And the other information we need to find by using a graph. Later I will explain. Okay, for the left side is a graph to find HF per 100, diameter of duct, and FPM. And then we'll get all information from the left side graph. And for the right side graph is to find side of rectangular duct. So the graph given. So for the pressure drop, the formula of pressure drop is HF per 100 times by duct length over 100. So we will find the pressure drop. So for the procedure, for the first step is floor plan drawing and choosing building specification. Second step is calculating cooling load estimation. Third step is determine the number of diffuser needed. And the fourth step is calculating equal friction. And the last step is draw final drawing with ducting system. And this is an assumption of design requirement for every room. And for the size is as in the figure I shown before. And the height of wall is 12 feet. And the walls is 4.5 brick wall with cement plaster on both sides. And for window glass north is 25 feet times by 5 feet per unit, and the west is 25 feet times 5 feet per unit, and for the south is 25 feet times 5 feet per unit. For east is 25 feet and 5 feet per unit, and the door glass is 5 feet times 7 feet per unit, and the roof is corrugated asbestos sheets, and the glass is 1/4 dark blue inside blind with external sheet, and ceiling is common suspended board ceiling, and lighting is fluorescent type, and room condition is 75 Fahrenheit, 55% RH and 72 GR per LB, and outdoor is 75 Fahrenheit, 55% RH and 72 GR LB, and the HN is 1.0 per hour, 1.0 AC per hour, sorry. Oops, sorry. And the last, not the last one, and for the result, sorry, cooling load estimation. Okay, this is a cooling load estimation table, and this is example for calculation for room 1, and therefore the right below is a result for every room RSH, and for more detail we can refer to the final report. Okay, this is number of diffuser in each room. Okay, for the room 1 is 4 diffuser, room 2 is 3 diffuser, room 3 is 3 diffuser, room 4 is 3 diffuser, room 5 is 2 diffuser, room 6 is 4 diffuser, room 7 is 4 diffuser. How to get this diffuser? As we calculate the CFM, we list all the CFM and we list all the CFM per diffuser, and we CFM divide by CFM per diffuser as I say in methodology, and the right one is throw radius. For room 1 is 11.88, room 2 is 12.92, and room 3 is 12.92, room 4 is 12.75, and room 5 is 10, and room 6 is 11.88, and room 7 10.63. And as I say how to get it, just plus length side and width side and divide by 2. For more detail, just refer in final report, there are more detail. Okay, this is equal friction result. Okay, there are too many sectioning, so I'm sorry for the error. So to see it more detail, we can refer in my final report. This for the design. This is a detailed design of ducting system. I added all this. I calculate and design the ducting system, and use SolidWorks to make this design, and we use FSU in this ducting system, and all dimension in ducting system has mentioned in this design. And diffuser chosen, we use Konica A. Okay, why we choose Konica A? Because the range of CFM still fit in our calculation range, and the size is still fit in our calculation. The size of Konica A diffuser is 160 until 500 mm, and the CFM is 142 until 2174 CFM. And for more advantage for this diffuser, because it is circular adjustable vent ceiling diffuser, and all size in stock, and it facing directly to a circular duct or plenum box by screw or pop rivet. Sorry. Alright, for air conditioning system selected is multi-split air conditioning. Why we choose multi-split air conditioning? Because multi-split air conditioning is fit with our flow plate selection, and all the specification of multi-split air conditioning is still fit with our calculation. And more advantage of multi-split air conditioning, these air conditionings are, as when we put as many as we want air conditioning, even though more in indoor unit, but just put the list of outdoor unit. Is not same like single split air conditioning. For single split air conditioning, for one air conditioning, we need to use one outdoor one outdoor unit. But for this, when we put as many as we want air conditioning, we just use one outdoor unit. And the more reason of choosing this multi-split air conditioning because it has various type of design. There are, for example, ceiling air conditioning and floor air conditioning, and moreover. Okay, discussion and conclusion. Okay, to recapitulate, based on this mini project, we learn and able to do ducting device operates, which are including ducting drawing and ducting calculation. Calculation on cooling load estimate also included on the operation. The ductwork is responsible for transmitting to all sections of building or room, and the supply air is generated by heating and air conditioning system. By experience in making this project, we also learn how to use graph to measure FPM, CFM, ducting diameter, and circular duct. From all learning in this project, finally we have an experience to install air conditioner with knowledgeable and properly. So this is all reference that I use to collect the information, and this is the last one. So that's all from me. Thank you.